In this video, I'll be talking about the superposition of the electric potential. Okay, and again, it is the electric potential, not the electric field. So now let's say you have multiple charges Q1, Q2, and Q3, and these charges are located at the different locations, and we are interested in finding the total electric potential at point P. Okay, so we are now trying to find out the total potential at this point P due to charge Q1, charge Q2, and Q3. How do you do that? And remember, the potential is a scalar quantity. It's not a vector quantity. That means it has only magnitude, not the direction. So what does the superposition principle tell you? The superposition principle tells you the potential at this point is the sum of potential due to all these charges. If you find out the potential at point first, find the potential at this point due to this charge, then due to this charge, and then due to this charge, and then add them together. That is the electric potential. Mathematically, that's what it is telling you. V stands for the electric potential. The electric potential now is given by potential due to the first charge, due to the second charge, and due to the third charge. And if you have many more charges, you can keep adding them together. The potential due to the first charge is given by K Q over R1, where Q1 is the charge of the first charge, and R1 is the distance between the charge and the point where you're trying to find out the potential. Q2 again is the discharge, and so on. And you can write down in form of summation in a more condensed form that the total charge is given by KQI times RI, where I is the variable, and it can vary from 1 to the number of charges you have. So this is how you calculate the superposition principle of electric potential. Now let's say talk about a special case where the charge is not a discrete charge. In this case, all the charges are discrete charges. But now there could be a case where the charge is not a discrete but continuous. So let's say, for example, let's say you have a plate, like a plate here, and this whole plate is charged. This entire plate is charged, so the charge is everywhere. It's not like at one location, it's everywhere. And we are interested in finding out the potential at this point P. How are we going to do it? Again, we're going to use the superposition principle. In this case, you have to find out if we just divide this entire disk into a small fragment, into tiny charges, that you have to find out the potential due to all these tiny charges. Find the potential due to this charge here. Okay, and there will be many charges. So, but the most simpler way is if you just integrate. This is how you find out. So you take one tiny charges here and then find the potential at this point and then integrate over the entire region. Then that gives you the potential due to a continuous charge. Okay, so it's again the superposition principle, but here not in the discrete charges but due to a charge itself, due to a charge disk or a continuous charge. So remember, for a continuous charge distribution you have to integrate. So this is it for how to find the electric potential due to a charge distribution. Here I found out one minor mistake here. It should not be electric field, it has to be electric potential. Let me write down, use the red ink. It is the electric potential. Okay.